All right, so today we're going to continue with object-oriented programming. We're going to actually be focusing on the fourth pillar, which is polymorphism, which in my opinion is going to be the most powerful, most long-term when you get into object-oriented programming. It's going to be the most powerful thing that you can do with objects and with object-oriented programming. Just to remind you, we are online, so if you have any questions, go ahead and post to Piazza or to YouTube. Since it does look like we've got more people online today than in person, that is. Again, what does polymorph mean? I think it's Greek. Poly meaning many, and morph meaning form. So in other words, many forms. And I think that the term actually originated in biology, where you have different phenotypes within a species. For example, different coloring or different like stripes instead of spots or something like that. The classic example is dogs. All dogs are the same species. All domesticated dogs are the same species. But of course, nobody would ever mistake a Chihuahua for a Saint Bernard, right? Those are different phenotypes. Those are different polymorphisms within a species or a subspecies, right? So in the context of code, it simply means that a variable, method, or class may be applicable to many different types of classes, right? Or have many forms. Right? And we've seen this before in other languages. For example, well, not just in Java, but remember that C has weak encapsulation. You can create a structure. It doesn't have classes or objects, but you can create a structure. So it offers the first part of encapsulation, the collection of data, but not the other two. Likewise, it offers weak polymorphism. For example, in C, how do you sort? What function was it in C that we used to sort? Q-sort, right? Did we have a Q-sort for doubles, and a Q-sort for integers, and a Q-sort for strings, and a Q-sort for transactions, students, et cetera, et cetera? Do we have 50 different Q-sorts? No. We only have one Q-sort. It operated on generic void types. Right? And then you had to plug in a comparator that applied to a specific type, but otherwise it was generic code. In other words, it's generic programming. You can create one variable, method, or class to have a generic solution to multiple types. You can create one sorting function that sorts anything, and all you have to do is parameterize it with a comparator of some sort, right? In Java, it means that you can, there are several different forms of polymorphism. And we're going to look at several of them today. And in fact, if you look at other object-oriented programming languages, there are even more polymorphic forms, metaprogramming and stuff like that, that we won't necessarily get into here, but you should be aware of them eventually, right? So the first type of is going to be subtype, or actually, let's head it like this: subtype polymorphism. So when somebody says just polymorphism, they're usually talking about this default subtype polymorphism, right? Where in Java and other languages, you can treat a class as its superclass, right? So for example, what were we working on this last week or so? We've got products and items, I think, right? There's an item, and we've got two subclasses, a product and a subscription, right? They both extend item. So we can treat a product like an item, right? So here's Java. I can create a product or item, I, is equal to new product, and I won't go with the full 9 here. I'll just say have some fake code there, okay? Let me zoom in a little bit more. Right? What am I doing here? I am taking a product, which is the subtype, subclass, and I'm treating it like the superclass. And then I can do the same thing with a subscription, right? Item I2, right? Subscription. Why would I want to do this? Because then I can put them into a list of the same type. List of items, right, is equal to new array list. In fact, I'm doing it a second time here. What is an array list? It's a list, right? So I'm treating the subtype like the supertype so that I don't have to worry about the details. And in this particular case, I can add both of those items to the same list. So I'll just go L here. L dot add I1 and L dot add I2. So subtype polymorphism, by treating subclasses as their superclass, I can have one list that holds all the types, right? I can have one receipt. In fact, let me rename that receipt. Is that how you spell it? Anybody? Okay. I before E, except after C. Exactly. Right? I've got one receipt here that can hold multiple different types. A polymorphic list. It can hold any type that you want as long as it's an item. Right? That way I don't have to maintain a list of products, a list of subscriptions, a list of. Right? Do you remember what this is called when you take a subtype and you treat it as the supertype? It's a variance of some type. The safe one is always covariance. Right? So subtype polymorphism is where you treat a subtype like its supertype. You can get even more generic than that. For example, if you don't need to know that the items are stored in a particular order, you can go all the way back up to the root of the entire hierarchy and say that this is just a collection. It could be an array list. It could be a hash set. It could be anything that you want it to be, and you've made it more generic. Why would you want to do something like this? Because then, which demo do I want? Close these two. There we go. I'll bring this up. There we go. I've created some apples, bananas, and cantaloupes, which are all products. I've created an Xbox Live, Cheese of the Month Club, and subscription to tap water here, right? Yep. You subscribe to tap water, right? How do you subscribe to tap water? You pay your water bill each month. It's just a made-up thing here, right? Anyway, I've got some products and subscriptions, okay? Now, if I've got a list of products, that's one thing. If I've got a set of products, that's another thing. So what I want to do here is I want to go over to my store, and I want to create a method that totals all the items. Let me try. Public, static, void, or not void because I'm going to return the total, right? Get total, right, of all the elements. So a list of products, right? Product and products. This should be pretty straightforward, right? Just declare a variable, total, initialize it to 0.0, because uninitialized variables are undefined in Java, return total. If I did not initialize this, no compile, right? So initialize to 0, and then I want to iterate over all those products, and for int I equals 0, I is less than products size I++. And I'll get the ith element, products dot get I dot get cost, right? And I'll add it to total. That looks like a pretty straightforward solution, right? Now let's go ahead and use it over here in my demo class. Right? Let's go ahead and total up all those products. So double subtotal 1 is equal to store demo dot get total of products. Excellent. But what if I had a set of the same products? Could I reuse that same code? Nope. If I have subtotal 2, but I give it a set of products, it's not going to compile. Why? It's a list of products. All right, fine. Solution proposal A. Copy, paste. Get total of set of products. And I'll have to import this. Right? And obviously it won't work. Why? Because can you get the ith element of a set? Nope. So let's fix this code before we decide that we need a duplicate code here. What should I do first? An enhanced for loop, right? So for each product, P in products, there we go. I will go ahead and go with p.getCost. There. That works. And I can get those two subtotals. I don't care about printing them out. I don't actually care how much this actually is. Right? All right. Good idea, bad idea. Bad idea. Don't repeat yourself. What is this doing? It's creating a total, iterating over a list, or it's iterating over a set. It's doing the exact same thing and summing them all up. In fact, I could take this code right here, this better enhanced for loop code, and I could put it up here, and it would not change anything. Exact same code for both of these. So, subtype polymorphism. How could I write one function to rule them all? Right? How could I change this so that it applies to both lists and sets? Using a collection instead. So let's change this to a collection. And let's get rid of the second one here. Of course, I have to import that. There we go. Now let's go back over here to the demo. I've only written one function, but it applies equally well to a list of products and a set of products. Awesome. Right. So that's the power of subtype polymorphism. If you use the more generic type, then you can get away with less code. Less code in general, it means fewer failure points. It's less brittle, right? Less testing, et cetera, et cetera. Less is always more, right? So you always want to go with the simpler function. We're going to come back to this example and make it even better after this, okay? Before we do, though, let's talk about overloading. Overloading. In fact, let's talk about method overloading. So another type of polymorphism is where you don't have to write additional function names. So as a motivating example here, how do you compute the absolute value in C? What's the answer? It's in the math library, hint. Do you remember? Abs. That applied to what, though? Integers. And one of the most common mistakes we see in the beginning of a C class is using abs on doubles and then losing precision because, of course, it converts it to an integer, right? Integer truncation. So what's the solution? Fabs. Right? And in case you didn't know, there's also labs, lalabs, falabs, and a whole bunch of other things. I think that there are at least a half a dozen of these things. But what? They all have the same function, but different names. Functionality, I should say. Right? They're not the same function, physically, like actual code function, but they all have the same functionality, just different names. All right, what about in Java? Math.abs, right? So is there only one abs? Let's find out. Math abs Java. Where is there? I have to. The Java docs are like the 6th hit on this. That's terrible. Anyway, yeah, I mean, it's just going to be a bunch of crappy tutorial point sites that are nothing more than ad farms. But I never see it because I've got, let's see, I've got Privacy Badger, Ghosterly, what else? DuckDuckGo, Privacy Essentials, Ad Blocker, and uBlock Origin, and oh, that's the enhancer for YouTube. I haven't seen an ad in 5 years. So whenever I go over to a computer that I don't have control over, and I see all these, like, what the hell? Just an absolute eyesore. I haven't seen an ad on YouTube in years, in a long time. I'd forgotten that they actually play ads on YouTube. All right, you should do the same. Right. Anyway, do we only have one absolute value function? Nope. We have one for doubles, floats, integers, and longs. In fact, let's take a look at the source code here. Math.abs. Actually, no, let me go ahead and write some code here. Int a is equal to negative 42. Double b is equal to negative 42.5. And I'll go math.abs of a and math.abs of b. Right? Is that calling the same function? Let's find out. Follow the breadcrumbs. There's the first function. It takes an integer and returns an integer. And by the way, has everybody seen the ternary if then else operator? Good? All right. No? All right. Then this is an if-else-if statement here. If A is less than 0, that's the question, right? If this condition holds, then the expression takes on this value. Else, it takes on the second value, right? So if it's negative, what does it do? It negates it. So negative 42 becomes positive 42. Otherwise, the original value 42 is returned. Right? Let's go back over to my demo, and let's see if that's the same function when I go to B. Nope. Different function. One that takes a double, returns a double. But guess what? Exact same functionality. The big the difference here is that it places a D in front of it to force it to become a double, right? And then it subtracts it. Why? I'm sure that there's some floating point reason for doing that, right? Going 0 minus instead of just simply minus. Right? I'd have to dive into that further. But in any case, they are different methods, right? There are 4 different methods, each taking a different type of parameter, right? But doing the same thing. But in an OOP language, we can use the same function name. This is known as function overloading, right? Not overriding, right? So careful. Function overriding is with inheritance, right? Subclasses override, or can override, I should say, override inherited virtual functions. Right? That's overriding. Overloading is overloading the value. When you say overloading, right, you're stacking things on top of stacking things. You're overloading a burden or something like that. You're overloading the meaning in this case. Math.abs has 4 different meanings. It's all the same functionality, but it depends on what you pass to it, right? And again, this is known as function overloading, right? How does this work? Compilers are dumb, but they are smart enough to figure out what type of variable you are passing. So think, I'm a compiler now, and I'm going to go back over to this demo here. Oh, you want the math.abs. Oh, there are four of those functions. Which one did you mean? Oh, you passed in A, which is an integer. Oh, you meant that first one. Down here, you're calling math.abs. Which one did you mean? Oh, you're passing in B, which is a double. You meant that other one. Right? That's called static dispatch. Right? So this mechanism is called static dispatch. All right? It's called static dispatch because it's dispatching where you go. Right? Which of these functions did you mean to call? I'm going to go ahead and deduce which one by looking at the parameters. Oh, you meant that one. I'll dispatch you to that function over there. It's called static because that happens at compile time. The compiler hooks up this code to hooks up your call to a particular code based on what you pass it at compile time. Right? That's in contrast to, remember, dynamic dispatch. Right? Find dynamic. Oops. Oh, over here. Find. Oh, I can't search. Okay, no, I can. Okay. When calling an object's methods in a subclass, dynamic dispatch is used to look things up in that virtual table. Remember when you create an ostrich, you create a robin. Thank you. When they're created, these virtual tables are created with references to the correct method. Then at runtime, it says object invoke your speak method, and then it goes and finds the right method for tweeting or for honking or whatever it was. Right? That's done at runtime because a compiler can't predict, is this going to be a robin? Is this going to be an ostrich? I don't know. It's going to have to be done at runtime. And in contrast, method overloading, or is done statically at compile time. We've used these two words before. Remember static analyzers? Actually look at your code before you compile it. We use GCC as a linter, the WAL flag. Dynamic analyzers like a debugger will analyze your code when it's actually running, or a profiler. It'll analyze your code for whether or not it's efficient, or what's taking the most time in your code. This method, this mechanism is called static dispatch. You can do the same thing with operators, although you shouldn't. Operator overloading. Right? So operators in a language may have multiple meanings depending on their operands. So for example, in Java, Java. If I do the following, string plus string, what's that meaning? What does that mean? What does the plus operator here in this case mean? Concatenation. They're not trick questions, right? Int plus an int. What does that mean? Addition, right? What about a string plus an int? You can do this in Java, it's no problem. Convert the number to a string and concatenate. Concatenate. Yep, I spelled it correctly. Right. Cool. Right. That allows us to mix types, and everything means concatenation, concatenation, concatenation when you've got at least one string there. Right. All right. Let's look at another language. Say, I don't know, PHP. What if I do int plus int in PHP? How is that interpreted? Straightforward, addition. What if I do string plus int in PHP? Does that convert the integer to a number and then do concatenation? Nope. What happens? Type juggle the int to a, or type juggle the string to a number, if possible, and add and addition. In PHP, what if I do string plus string? Do you remember what happens then? Same thing. You must mean addition, because plus in PHP only ever means one thing: addition, 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 right? So type juggle times 2 and add. How do we do string concatenation in PHP? Do you remember the operator? It comes from Perl. No? We didn't do it? Or you got assignment 1 done and then you threw it all out. I'm never going to use PHP again. Right. Dot. I don't know, if you want to. may have to someday. I mean, if you want to do any, it's still run on a huge number of websites. If you ever do any like Drupal or CMS development, content management systems, Drupal or whatever else is out there, it's for the folks that don't know how to code and they just have WYSIWYG websites, right? But if you want to go and do back-end stuff to develop stuff for those websites, you're probably stuck in PHP land. We haven't covered Python, but some of you might. Anybody know Python? A little bit? No? All right. So I'll explain it then. Int plus an int is going to be, of course, addition. That would be super weird if it meant anything else when you've got a number plus a number. But if I go a string plus an int, actually, let's do a more meaningful one first. String plus string is concatenation. That's perfectly fine. But when you go with a string plus an int, guess what happens? It's nothing like any of the others. Error. You basically have to explicitly convert the integer to a string and then concatenate. Right? This will not throw an exception, well, throw a runtime exception or interpreter exception or something like that. But it's not even going to allow you to do something like this. I forget this all the time. And then basically you have to to get it to work, you have to wrap up the integer in this function call to str to force it to become an integer, to force it to become a string. Right? I forget it all the time because I'm used to these other languages that do something completely different. 3 languages, 3 completely different behaviors. Right? But that's what operator overloading means. It means in a different context, a plus has a different meaning. With even just a simple mixing of numbers and strings, you can see the confusion, right? If you go from one language to the next, everything that you knew gets thrown out of the window, right? It can get even worse. What about other contexts, right? So, for example, what if I have a list plus a list? How would you interpret that? I've got a list of products and a list of subscriptions. If I add them together, what does that mean? I don't know. Right? It could mean append. What's another possible interpretation? Union. Right? What's another possible interpretation? Has anybody done vector calculus yet, or vectors? Right? XYZ, ABC. If I add these two vectors together, these 3-dimensional vectors together, what do I get? A new 3-dimensional vector that's x plus a, y plus b, z plus c, right? And right, that's vector addition, etc. What if I did set plus set? I have no idea. What if I did time plus time? Duration probably makes sense, right? Duration plus duration. If I said 5 hours plus 30 minutes, 5 hours and 30 minutes, that makes sense. But what about time plus time? Thursday, February 17th, 2:30, plus February 18th, 5 o'clock, that's when, 5:30, that's when baseball starts tomorrow. I've been waiting a long damn time for baseball to come back. 5:30 tomorrow, that's when the Huskers play. So be there. I printed out all my scorecards for this. Actually, no. I need to get my scorecards. Oh, well, they're not playing in 20-degree weather. I think that they're playing in Texas to open it. They are playing pretty early here. They play in Hawks Field. Just over the bridge.
For baseball?
Yeah, for UNL baseball. Yep. All right, but what is duration? So duration plus duration. That's straightforward. What about time plus time? Ill-defined. Does this sound like a good idea to get into? Probably not. Right? Some languages like say PHP, Java, Python, have predefined meanings for operator overloading. Some languages, say C++, allow you to arbitrarily overload operators. Right? Bad. Why? You could define anything you want. Right? You could redefine plus to be subtraction. Would you want to? Would you want to use somebody's library who thought it was a good idea to redefine the plus operator for integers to become subtraction? No. So, not a good idea to use this in practice. Right? In any case, even if you do, you're ultimately writing a function to do so. Right? In C++, you can override the plus operator so that when it's time plus time, it has this meaning. You specify that meaning by defining a function, putting it in curly brackets. If you're defining a function anyway, why not just use the function? Right? Give the function a sensible name, like add duration, or set union, or list append, all right? Give it a sensible name so that people know what the hell you're talking about. If you have to write a function anyway, you might as well just write the function. But you should understand and know that there is this thing out there called function or operator overloading, right? And why it may not be a very good idea to use it, okay? Okay, so I want to go back to parameterized polymorphism. I want to go back to this example up here, and I want to improve it even further. Let's go ahead and close that math class. Where's my store demo over here? Right, there we go. So I combined a list of products and a set of products, subscriptions, and I made it general so that it was a collection of products, so that I wouldn't have to write another function, another function, another function. Right? Now what I want to do is I want to add up the sum total of subscriptions. Can I get a subtotal 3 by doing that with my subscriptions? Nope. Why? What does it expect? A collection of products. And this is a list, which is a collection, but it's of subscriptions. Okay? So what I want to do is I want to what's called parameterization. Right? In Java, you can create variables. Right? For example, int x is equal to 42. Right? There we go. What type is x? It's an integer. Its value is 42. Its value can be changed. I can change it to 43 later on in the program, right? But can I change its type? Nope. When declared, a variable has a set type. However, you can parameterize a variable, method, or class so that the type is not set. Let's take a look at some code here. Now, this is not real code yet, but we will see code like this eventually. T sub x. All right? So x is a variable. What's its type? Is it an integer? Is it a double? Is it a string? Right? It's t. T is a variable. In fact, there's nothing special about the name here. T is just simply short for type. You could have type like this. I don't know what its type is, but we usually just go with a single letter here. T, S, E for elements. You know, single letter variables here, because that's the type of variable. Right? Now you can do this. Just you have to parameterize it. Right? T it refers to to a generic variable type. That is not known at compile time, necessarily. Right. We've seen this before, say in C. How does qsort work again? Qsort takes an array of doubles, or it takes an array of integers? Nope. What does it take an array of? Void pointers. Right? It takes away all type information about the array that you're passing in. Here I've taken away all type information, but I have made the variable type into a variable itself. Right? It can vary. It could be a string. It could be a double. It could be an integer. Right? It all depends on how you use it. Right? All right, so let's see. What do I want to do? Let's come over here and tutorialize this so that we can walk through a much better solution in our store demo here. I want one function to rule them all. Right? This function so far is ruling only one type, products. Okay? How could I change this so that it is ruling both products and subscriptions? Instead of getting total for products and copy pasting and changing this to, what was it? Subscriptions. Thank you. Sub. How? The only time you copy paste is when you don't know how to spell something. Or you don't want to type it out. There we go. Change this into a subscription, and of course, S, and then subs, and then S here, right? Subs. Right. Do you want to copy paste like that though? Nope. So let's make this more generic. I'm going to parameterize it. T. All I'm doing here is declaring that there is this generic type T. And this is a collection of those types. Right? And I'm not talking about products anymore, am I? I'm talking about T's. And I'll not call it products, I'll just call it stuff. There we go. S and S. There. S for stuff, or thing, and then T if you want. But I don't want two T's there. TT, no. What's the problem though? Yeah, what is T? It could be a string. It could be a double. Does a string have a getCost function? Nope. So I need a little bit more information here. Okay. T, what is it? Right? It could extends item. Okay. And guess what? Item has a getCost function. Even though it's abstract in the item class, it's concrete in anything that you would pass in. Products or subscriptions or generic items. So I've given this a minimum of information in order to give it a minimum of interface so that it can actually work with this stuff. Now let's go back over to the demo here and see, guess what? Now I can use that function on a list of subscriptions. Not only that, but what else could I do? I could create a list of items, item, everything, right, equals new array list. And I could add everything. I could add, products. I could add everything, add products, subs, right? And then I could add all. That's the add all, and then I could get a grand total of everything. Right? That's cool. Now I only have to write one function to sum up all of my products. Not only that, but in the future, if I create a brand new type of item for my store, like a gift card, do I have to change this code at all? Nope, I just have to put it into my inheritance hierarchy. If I subclass a product, and I've got like a liquid product or a solid product or whatever, I make more specializations. Do I ever have to change this? No. Okay. Yeah, go ahead.
Is the reason why we have to extend item is because item is abstract?
Not necessarily abstract, but I need to know something about T's. What do I know about T's without that? Nothing. I can declare a T, Tx, right? What is X? X dot, let's find out. It's got an equals function. It's got a get class, hash code, notify all, string, wait. What is it? T is an object. Tx is no different than object y. T and X, they just have the same information. Right?
What's stopping you from changing T to like item?
I could. Excellent question. Well, I wouldn't do it here. I would just say item. I'll just go with item. I'll keep it as an S here for a second here. This is perfectly fine, but guess what's broken? Everything before.
Yeah, because you said it as product.
Yeah, now it has to be a collection of items. It cannot be a list of products. Right? Even though a product is an item, by making that it's an oxymoron, but we've made it too strictly generic.
I get it, yeah.
Right?
That makes sense.
So, going back to this, T and T extends item. Now this allows you to do a collection of products, a collection of subscriptions, a collection of items. All three of them, right? Best of all three worlds. and anything in the future that you happen to put in your hierarchy. Right? And everything over here is now fixed again. Right? Yeah?
So when T extends to items, it can take in anything item or anything below it.
Yeah, fill in the blank here. It could be items, because items extends items. It could be product, because product extends items, right? It's just T, right? And it's a collection of T, right? But, oh, and then let me restore that there, right? Okay. Do I need the T's though? I wanted to do something else, but I might have coded myself into a corner, painted myself into a corner. Okay. I don't think so. All right. Do I really need the T, though? Let's find out if I need the T or not. I'm going to put in a question mark here, right? In fact, I'm not even going to put it here. I'm going to take away this parameterization entirely and put it over here. There. We'll worry about down below here in a second. Okay. Did I use T at all, other than did I actually pull something out of the collection and then I did in a sense, and I got its cost, and so I could add it over there. But did I do anything meaningful by pulling it out of the collection? Not really. This question mark here is, I don't care what the name is, because I'm not going to use the type. I'm not going to declare a variable with that collection. Right? Now, I am down here. I end up having to do so. But if I did something else, for example, I could say if stuff.size is equal to 0, then throw new runtime exception, no sale. You asked me for a total of stuff, runtime exception. You asked me for a total of stuff, but who cares? There's nothing in there, right? And I'm going to throw that back at you. Right? If you don't actually use that variable t, then you don't need to create a variable t. And so this question mark is what's called a wildcard. It'll match anything you want. We don't care what the name is. Okay. Let me go ahead and roll it back here now. There we go. And can I get away without that? Without that? Is there a way to iterate over this to get the cost without the actual t? For int I equals, no, I can't do that because I've already extended it to a collection. Okay. In this case, I do have to use t, I believe, because I am iterating over it, and I need to get a hold of it, s, right, so that I can get the cost. Right? I'll show you another example where that's not necessarily the case. So restore this too, and there. Now we're all back. Okay. All right. Let's see. Now I want to do another task. I want to filter everything that does not have, or that has a cost of 0. In other words, if over here in your demo, you bought, instead of 4 apples, you bought 0 apples, let's get rid of that. Right? I don't want that in my receipt, right? Because you zeroed it out, you canceled the sale or something like that. I don't know what the appropriate scenario would be, but whatever, right? So let's do that method now. I'm going to steal this to start out with, because I want it to apply to any collection of stuff, right, that is a collection of some sort of items, okay? And I will iterate through it, and what I'll do is I'll put it in a different bag, right? So collection of t of invalid, right? And I'll go through my stuff, and if s.getCost is 0, then I will go ahead and go invalid.add s. And then here I'll just return. It'll be a void function. There we go. Right. Now, do you see what I was doing here? Right. I'm just taking, you give me all of your stuff, I go through it and say, oh, this one, this doesn't cost anything. Put it into this bag over here. I'm not taking it out of this bag. I could do that if we wanted to, but I'm just going to go ahead and put it in this bag over here. Okay? What is this a bag of? T's, right? That means that I would be forced to match the same collection over here. Right. For example, let's come over here to demo, and let's try to filter purchases. ... Store demo. Dot. What was it called? I shouldn't call it get total. I didn't. I did call it get total, didn't I? Nope. Filter bad. Sorry for that. Again, only two difficult things in computer science, right? I want to filter bad. I want to filter my products here. Okay. And here's my bad bag. So bad ones. I need to, of course, create that. So I'll create, I don't know, a set of purchases equals new hash set of purchases. Or purchases, what am I saying? Is it products? Products. There. A set of products. I don't need to parameterize that second one. There we go. Called bad ones. They're bad apples. I didn't even realize that I was going in that direction. What do you do with bad apples? You throw them out. Otherwise, what's the idiom? One bad apple spoils the bunch. Right? Okay. This works. Why? What is products again? It's a list of products. It's a collection of products. What is bad ones? It's a set of products. Right? And guess what? We expect a collection of T's and a collection of T's that all matches. What if I try to be more generic, though, and say, I want to filter both the products and the subscriptions. So I'm going to go ahead and make this into a generic item, filter the bad ones, filter the products, and filter subs. It all breaks. Why? Products is what again? It's a collection of products. But what is bad ones? It's a set of items now. So how do we make this so that it works on anything that we could ever possibly give it? Now in this case, do you care about the T's? Do the T's have to match? No. Why should they have to? Right? But I do need some information about this. If I'm going to pull something out and then put it into a different bag, I've got to give it another bound. These are called bounds. Super item. There we go. Whoa, what just happened there? Let me go ahead and put this on the next line so that it's all in one. All right. So we're saying that there's this type out there called T that is any subtype of item. That could be item, that could be products, that could be subscriptions. And we're given a collection of those things. Okay? And we go through those things. We need a name to put it to so that we can get the cost. And if the cost is 0, we're going to throw it in that bag over there. But that bag doesn't have to be the same thing. This could be products and that could be items. This could be subscription and that could be items. This could be subscription and that could be subscription. All we care about is that it's at most an item. I don't want to throw it into a bag of objects. I don't want to throw it into a bag of strings or something like that. And so I put an upper bound on it. Actually, upper bound, lower bound, it depends on your perspective. But the T extends item is you have a minimum amount of information when you use the extends keyword. You have a maximum amount of information when you use the super keyword. Super, remember super? A super class, right? The super constructor, right? Super dot. That's how you can get access to the super classes stuff. And I don't care that the type has to match. So who cares? Wildcard, anything. Anything goes. And now over here, I can do whatever I want. This could be a set of products. Now this will break over here, but as long this one should work. Why is this not working? This should work. Anyway, I'll go back to items here. Anyway, this goes into not a design principle, but a concept called PEX. And let me go ahead and put it over here. PEX. Producer extends consumer super. It's just a mnemonic device to remember it. So if a collection, or a collection is a collection, like a list, a set, a collection, whatever, is a producer of elements, if you take stuff out and do something with it, you need a minimal amount of information. Right? You need T, say T extends item or something like that. If you don't have a minimum amount of information, the minimum amount will be given to you, and that minimum amount ends up being object. You can treat it like an object, because in Java, everything is an object or belongs to an object. Right? Everything is a class or belongs to a class. A collection is a consumer of elements if you wish to put stuff in. Right? And there we use a wildcard and then super and then item. Right? You don't care about what is in the collection already. You just want to put some new stuff in it. Right? And this is where we get the PEX. The producer extends. So if it's a producer, if you're treating your collection like a producer and you're going to be pulling stuff out, then you need to use the extends keyword. Right? If you're going to treat it like a consumer and you're going to put stuff in, then you need to use the super keyword. Okay? In general, I'll go out here. All right. In general, if you care about the type, you need to use a named parameter. And that's going to be, again, T or S or E or something like that. If you don't care, you might, and I'll emphasize might, be able to use the wildcard, which is question mark. Right? I don't know, I don't care, because I'm just going to be doing, I don't need to use it at all. Right? Okay. You will not probably have to design anything in depth like this, right? From scratch, that is. But you will see this notation all over the place in, say, the collections library, right? For example, let's do one more example here. Let's see. I want a method that returns the most expensive item. So public something, right? Something, right? Public static. Get max, say. Now help me with the signature here. Returns the most expensive item. If I start out with something very, very specific, like say a list of items, or even a list of products. There we go. And I'll go through, find the maximum, and return a product. Right? So how would I do that? Product P is equal to items dot get the first one, and I'll assume that that's the maximum. In fact, I'll call it max. And then iterate through the rest of them for product P in items. If P dot get cost is greater than max dot get cost, then I update the max to be P, and I return max. That's pretty straightforward implementation. Now help me generalize this. This only works for lists of products. How can I immediately generalize this? A collection of items, okay. In which case you would end up returning an item. But then that only works for collections of items. It will never work for, say, I can't get the maximum of, say, the set of products here, because this only operates on items, even though products are items. So let's change this so that it's T extends item. But now what's the return type? Now, 3 question marks here, because it's not going to be a wildcard here. If I gave you a collection of T's, and I asked you to find the most expensive one in there, and you gave it back to me, what would you be giving me?
T.
A T. Yeah, come on. It's not letting me highlight all that stuff. There we go. Too much. There we go. Come on. There. Right. So you give me a collection of T's, I find one, I'm guaranteed to give you back a T. Because I want an assurance here. If I gave you a collection of products, I expect a product back. If I gave you a collection of subscriptions, I expect a subscription back. If I gave you a collection of items, I expect an item back. I don't know if it's product or a subscription. I don't frankly care because I just want the most expensive one. Right? So that means down here that we're going to have to generalize this to T's. Right? Except now, what's the problem here? Can you get the 0th element? No. Items, here's the way that you do it. You have to go really old school Java here, Java 4 kind of style, dot iterator, dot next. The iterator gets you an iterator that goes over each one of them, and then get the next one that gives you the first one. Right? And that is not a product anymore. What is it? T. Now it works for anything. Right? Over here, what's the max? Item max is equal to, what was it? Store demo dot get max of everything. System dot out. Println max. So what's the most expensive thing going to be here? I have no idea. It was some subscription. I never did the toString method, so I don't know which one it is. I think it's going to end up being the Cheese of the Month Club here because it's $240. And I subscribed for the whole year. Can't wait for Brie month. All right. So that sounds like an excellent solution, except that, wait a second. We can take this a step further. The maximum is not just a concept for products and subscriptions and items. What else can you find the maximum of? Integers. What else can you find the maximum of? Doubles. Strings. The lexicographic maximum. Zebra is greater than apples, right? Anything that you might that is orderable, you might want to get the maximum of. Right? I wonder how that works with integers. Integer x is equal to 10, integer y is equal to 20. How do I know which one is greater? Well, x is less than y, x is greater than y, right? If it were strings instead, string a is equal to hello, or I'll go apple. String b is equal to zebra. How do I know which one is bigger? How do I compare strings in Java? A dot compare to B. What is that? What is that? It compares it lexicographically. We compare things using a comparator, right? This is a comparator. This is actually it's the same pattern, but this is actually a comparable, right? Let me go ahead and jump into that thing. What does it look like? This is the string class up here now, and there's the compare to method. It takes another string. They even call it another string. So my joking patterns of calling this and that, right? It's not that far off, right? So what defines this though? Let's go up here to the top of the string class, and we see that it is comparable. A string is comparable to what though? Another string. Right? So let's come back over here to the store demo, and let's say that, well, why do we have to restrict this to items? Why can't we just do this for anything that is comparable to something else? A T would only be comparable to something that is similar to it, though. It would only be comparable to what? Another T. Apples to apples, oranges to oranges, zebras to zebras. Right? Now, how can we change this function to find the maximum? We no longer have information because it's no longer an item. It's comparable though. And what does a comparable do? It has a p dot compare to the max. And if that is less than 0, then, is that right? No, greater than 0. They're in order, so it's not greater, so there we go, there, right? Then we update the maximum to p. Now, everything breaks over here. Why? Everything, and literally everything breaks over here. Are items comparable? Nope. Let's do it then. Comparable is an interface, so we use the keyword implements comparable. Now, are we going to compare items to strings? Nope. We're going to compare apples to apples, oranges to oranges, and zeros to zeros. So items to items. And, oh. Come on, where are you? Oh, okay. Well, it's not going to complain up here because it's abstract, so it doesn't care if you do it here. It does care if you do it over here in products, though. A product is comparable, but you have not implemented that method. So how do we compare a product to another product, or an item to another item? O dot get cost, right? In fact, let me go that item. So if this dot get cost is less than that dot get cost, then they're in order, so I return something, what? Negative, else if, and while I'm doing this next one, go ahead with your question.
Yeah, should we do this comparative items, or?
Yeah, good question here. Let me go ahead and finish this out. Return 1, else return 0. There we go. You're right. What am I comparing? I'm comparing a product to an item. Right? That's okay because all items have get cost, so this will compile. Right? And in fact, this entire class is fine with this implementation. What would it look like in subscription though? Copy, paste, copy, paste. These are subclasses. So if I'm copy pasting here, common functionality, what is that screaming out to me? Move them up. Right? Get rid of this. And I've copied it so I can get rid of it. Get rid of that and go back up to the item class, and that's where it belongs. And both of them inherit that functionality. Right? And guess what? Come on. Are you? Oh, I just didn't save it. There we go. All the compiler errors goes away. And guess what? Over here in demo, get max now works with everything, literally everything now that is comparable. Right? Let's take a look at that again. That seems like such a common operation that somebody else must have thought of it already. And they did. Collections dot get max, or dot max, I guess it is. There we go. Of items. What does it look like? Now, it's far more complicated here, and this is an example of where they really thought about the producer extends consumer super, because they're all over the place here. T, so it's parameterized and it's named, and it extends object or it extends comparable, right? So it's either an object because all objects are comparable. The default there, I think, what is it? Oh no, sorry, no, and it has to be an object. That's actually, oh. I'm actually questioning that. Why did they put that there? It extends object. Everything's an object. Why would you have to explicitly state that? I'm not sure why they would maybe that's some legacy thing prior to parameterizations. If anybody knows out there, let me know. But I don't think that this is absolutely necessary. They just extend comparable, and guess what? It just has to be a super type of T, excuse me, right? The consumer super, right? Because you don't care what's in there already. And then question mark extends T. And then what does it do? It gets the iterator next, right? And then While it has next, it goes through. It doesn't use an enhanced for loop because this existed before Java 5 or whatever it was. And so it's not using an enhanced for loop. It's just using a regular while loop. It goes through, and if the candidate is greater than, according to the compare to method, it updates it and returns the candidate at the end, max. All right? Why would that one be better than this one? Than the one that we did? Well, first of all, it's more robust. I think it would apply to more items, right? But it's already built in also. But another reason would be, what if you wanted to get the min? What would it look like then? All it would be is changing this to that, right? I wonder, does collections dot min of items? It didn't used to be there, I believe, but there's min. It is a full implementation, and all it is a flipping of this thing right here. Anyway, the point that I was going to try to make before they contradicted me by giving me this min was that, can you make this even more generic? In other words, don't make this comparable. Let's make another one. Public static t, and then get max other, and then it returns a type t, collection of t, right, items. What else could you give this XXX if it were not comparable? How do we sort students? Collections.sort, and it takes the students, the roster, and what else? A comparator for students, or in this case, elements of type T. And then you could use this comparator, instead. But you would still have to parameterize. Why? Because you don't want a get max other for students, a get max other for products, a get max other for whatever. Right? But you could do this as well. Question?
Yes. Two actually. So the collections not min, does it not take any comparator, or?
There's another version. I'm sure that's probably right after it. There we go. There's another version that takes in a comparator. So what's the difference between the two, though? Did you see? One of them gives a guarantee on T extending comparable. The other one does not have that guarantee. It just extends T. It's just a T, right? I don't know what it is. I don't care what it is, because you're giving me a comparator that consumer super cares about. I care about putting something in there so that it can process it and tell me they go like this, or they're equal. Right? Second question. Go ahead.
And also, super, does that mean like everything above?
Yes. So in other words, this could be a comparator for objects, and if I don't like it because it's kind of meaningless. Here, where are my slides? When I used to use slides like this, I would talk about why it's there are two different bounds here. Darn it, where is it? Huh, where is it? Come on. All right. So you can talk about lower bounds. Named lower bounds do not exist. For example, you could have something like this, right? A definite type, which is a super type of foo, right? So now we've got this in our hands. That would match a particular type, which is a super type of foo. It's not that useful, though. Why? What do you know about T's? Nothing other than it's somewhere up there, right? in since it's named and you don't have any other information about it, all you have is that it's an object. So it's kind of useless. And that's why we just, not reify, but we don't usually use T here. We just use question mark because what's up there? I don't know. Who cares? Right? We're just saying that it's somewhere above. So it's an upper bound, right? Again, it depends on your perspective. The slides that I made a long time ago were calling this a lower bound. I can see how you're looking at it as an upper bound because you're already down here. What you're going to see in your lab on Wednesday, next week, is we give you an exercise that has you moving up and down the bounds. So what we do is we give you a course registration system, where there are some courses where you've got undergraduate students and graduate students, and then droids, which should not be allowed to enroll in our courses because we don't like their kind here. Right? Star Wars, in case you've ever seen it. Right? Everybody's seen Star Wars, right? But anyway, if you're in computer science, you've seen Star Wars. I think that's a safe assumption. Anyway, you've got some courses that graduate students can enroll in, other courses that only undergraduates can enroll in. How do you change these parameters to restrict that or to allow that? How can you create a course where you can have a mixture of undergraduates and graduates? And then how can you restrict this other type from joining in, right? And so you're going up and down the inheritance hierarchy, finding exactly where you want. Not too low, because you want to keep it generic. Not too high, because you need a minimum amount of information in order to work with them. So it's just Goldilocks, right somewhere in the middle. And PEX, producer extends, consumer super, is the guiding principle there. Again, we're not expecting you to get too far into it, too deep into it. I would be very, very hard pressed to design this from scratch myself, right? But once I see it, I could say, okay, I understand why you did it that way. I've seen I've designed some systems like this before, or some classes like this before, where we wanted to be really specific, and then it is quite elegant. What you can do is you can set these parameters up, and then you just, as a colleague of mine once said, once you've set up the dominoes, right, and you just tap the first one, everything else falls into place. That's design. Once you've got the correct design, right, and then everything else is just, oh, this is easy. This is on cruise control now. I can just write this stuff and it all falls into place because of that well-designed inheritance, or that well-designed polymorphism. And that's why I don't reinvent the wheel. I'm just going to reuse what they've got. Right? All right. We'll review some of this on Tuesday, but more to the point, we're going to focus on the solid principles. So I have solid principles. Just the last 3 minutes here, I'll give you the acronym. Come on, I just want the acronym. I don't want to background. There we go. So it's an acronym. These are just 5 concepts that we've already covered. Remember, I gave you 4 pillars. Out of that come 5 concepts that can be cross-listed to each one of these things. Right? The single responsibility principle is just simply good encapsulation. Address class should only be responsible for address stuff. A data loader class should only be responsible for data loading. A data converter class should only be responsible for data converting. Right? Separate things. Open-close principle, that's with inheritance, that it should be open for extension but closed for modification. I forget what it was, that is. The Liskov substitution principle, I hinted at that when we looked at the rectangle problem. Right? Don't define inheritance hierarchies that are easily semantically broken. The interface segregation principle is keep your interfaces as small as possible. Either 1 or even, in some cases, 0 methods. Right? 1 method, 2 method, 3 methods, that's way too many. Split it up. Right? Segregate them off into different responsibilities. The dependency inversion principle is the coolest, though. And when we get to that, we'll see it's not an inversion at all. It's this thing depends on this thing, rip it open, and have it depend on an interface in the middle. So that there's no independent, that you've got this dependence, this thing depends on this thing, right? Separate that out so that there's not a hierarchy. They just depend on some commonality between them. Right? Those are the solid principles that we'll go over in detail later on. And then there's another 4th one. I forget what, a fork or something like that. People like to come up with acronyms and reinvent stuff all the time. All these are just reinventions of those 4 pillars. So we'll talk about that next time.